So before we get to solving, a couple of these we're going to simplify, okay, because it's going to help us later. We're going to do a little bit of heavy lifting now. It's not really heavy lifting, but we're going to do a little bit of now prep work before we get to the lesson. So simplify that. What does the squared mean? Anytime you see a squared, the outside, the little 2 on the outside, what does that mean?
A number times the same number.
Okay. So in other words, that right? Okay, well, let's keep it going. How do we multiply anything? We did this last week, maybe the week before too. How do we multiply anything with a square root? What's the rule for multiplying roots? Can we multiply them to make 4? Yep. If they have the same radicand, if they have the same root, we can multiply what's on the inside. If one of them was on the outside, I couldn't do that. All right. Only multiply radicands with radicands and coefficients with coefficients. Okay. So the square root of 4. What is the square root of 4? 2. So 2 is my final finished product answer, right? Okay. Let's do B. So this one again means the square root of 9 times the square root of 9. Right? They both have a root, so we can multiply what's on the inside, the radicand. That's 81. What's the square root of 81? 9, right? Good. So look at A and B. Look what you wrote down for A or B. Is there a way for me to go from question to answer without having to do the middle part? What am I doing every time here? How can I skip the middle part here and just go right to the answer? What's the pattern that you're seeing?
It's always like multiplied by 2.
So I'm multiplied by 2, right? And that's how we simplify it, right? But how can I do this and go from this right to there without having to do any of this stuff here? There you go. Isn't it just removing this and this? Aren't they kind of canceling each other out, and whatever was in here is in here, right? That's because squaring and square rooting are inverse operations, right? Remember when we used to add 10 to both sides, and then the number we crossed it out because it went away, right? It's the same thing. Squaring and square rooting cancel each other out. So if I'm squaring a square root, whatever was on the inside, that's the answer. Okay? So what is C going to be? Plain old X. Good. What is D going to be? X plus 5. Yeah, so we can skip all of that middle stuff and just go right to the answer because you're just doing the opposite. And when you do that, the root, the radical sign, and the power go away because they cancel each other out. Okay? All right. Okay, so that's just a little bit of, it's going to help us later. Okay, so these are the steps. They're written on the board too. First thing we got to do, anytime we solve, we want to isolate. Okay, so in this case, we're going to isolate the radical on one side of the equal sign. When we do that, we're going to do what we just did. We're going to square or cube to get rid of a radical. Because doesn't that got rid of the radical? I don't have a radical anymore. Same thing over here, right? And then we're going to simplify and solve. So step 3 is going to be very familiar. Step 3 is the step we've done before. Step 4. So step 1, 2, and 4 are new. We're going to check for what's called extraneous solutions. Extraneous solutions are solutions that don't work, and I'll explain what that means when we see one. Okay, so let's do number 2. First thing I'm going to do is I got to isolate. Step 1 says isolate the radical. Well, that means I have to know where's the left side and where's the right side. So I draw a line on the equal sign. So the radical is here, right? That's the radical right here. I need to isolate it on the left side. So the way to do that is to add 4, right? To get rid of the 4, to make the 4 go poof. So I'm going to add 4 to both sides, right? That makes it disappear over here because minus 4 and plus 4 are inverse operations. So now I have x plus 2, the square root of x plus 10 there, and I have a positive 3 here. Step 1 is done. The only thing on the left side of the blue line is the radical. There's nothing else there. Okay, let's go to step 2. Step 2 says square or cube. Well, this sign here, this radical sign, is this a square root or a cube root? It's a square. How do we know that? Yeah, no number there, right? No number there means it's square root. So that means I'm going to square both sides. I got to do it to both sides because whatever you do to one side, you got to do to the other. Okay, look at the left. Doesn't the left side look like one of the problems we had up at the top? 1D, doesn't it look like 1D? So what do you think that's going to simplify to? Just a regular old x plus 10. Yep. The root and the radical sign and the power are going to cancel each other out. And then over here, what is 3 to the second power? Positive 9, yeah. Step 3. I told you step 3 is going to look familiar. What do we do now? Step 3.
Take away 10 from both sides.
There you go. -1. X equals a -1. Okay. Step 4 is you got to check to see if -1 is actually, it is an answer, but does it fit into an extraneous category? How do you do that? Well, you're going to check the answer to see if it works. So checking answers means plug it back in. So I'm going to rewrite the problem. It's instead of x though, instead of x here, I'm going to write -1. Okay. -4. Sorry, yep, you're right, -4. Okay. So let's see. In here, I'm going to get the square root of 9 minus 4 equals -1. The square root of 9 is 3. Is that a true statement? Is 3 minus 4 equal to -1? Yep. So blue check, it's verified. Answer is works. Okay. The answer does work. It's not extraneous. Okay. So I want you to try number 3 on your own. Use this as a roadmap. Try number 3 on your own. I'll give you about 3 or 4 minutes. We'll go over it together in that time, okay? Okay, so subtract 11 from both sides to get the radical by itself, the radical sign. And then square it because it's a square root, both sides. And then your last steps, I should say, subtract 123 from both sides. You get -42. Divide by 7, divide by 7. I get -6 as an answer. Okay. Last step, number 4, I got to check to see if it's a verified answer, if it's an actual answer, or if it's extraneous. So anywhere I see an X, I'm going to put a -6 in there. Okay. So that's -42 plus 123. -42 plus 123 is 81. Square root of 81 is 9. So, and then I ask myself, does 9 plus 11 make 20? Yes, it does. So it's a verified answer. It's not extraneous. Okay, extraneous is if I got an answer and I plugged it in and I got something that's not equal on both sides. Then it's extraneous. We don't include it in our answer. Okay. Alrighty. Okay, so make sure you do that. A lot of people take that for granted. A lot of people take number 4 for granted. Step 4 for granted. And they don't do it. And then they put it into Delta Math on a test or a quiz, and then it comes back it was wrong. They get some of the points, they don't get all the points. They're like, well, what did I do wrong? Step 4. Step 4, because one of them was a solution, one of them wasn't. Okay? Okay, so let's look at number 4 now. Okay, we're going to follow the same steps that we've been doing. Okay? First step, isolate the radical. Well, the radical is by itself on the left. That's already done. They've already done that for us. Good. Next step, square. I got to square everything on here. Okay. Be careful when you square this side, because I've seen a lot of people do this. I've seen a lot of people do this over the years that I've taught this. They do this. They square both sides, but they do this. They go like this. They square this, and then they square this, and they're like, oh, it's just x squared plus 4. Squared both sides. That's not how you do it, because this is a binomial term here. This is a binomial term. How do we multiply binomials? One word, 3 letters. What do we use? 3 letters, starts with a B. A box. When we multiply binomials, we use a multiplication box. We've done that before. Well, it's squared, so it's itself times itself. So you're going to have x plus 2 on the top and x plus 2 on the side. Okay, so we multiply, we got x squared plus 2x plus 2x, and then the last one's positive 4. After we multiply inside the box, what do we do after that? Yep, combine like terms. So when I combine those, I get plus 4x plus 4x squared plus 4x plus 4. Okay. I want you to look at this guy now. Does this look familiar, like something we've done before? Yeah, we have. We've been doing this since 2 chapters ago. We've been doing these problems since 2 chapters ago, solving these types of problems, right? That's why I left this on the board. Binomials and trinomials, right? I left them on the board because I knew we'd be coming back to this. So this is a quadratic. The highest power is 2. So the first step is set it equal to 0. That's the first step for both. Set equal to 0. Okay. Well, that means I got to subtract 6x from both sides. Okay, 6x goes away there. I have a 7 over here. Over here, I have a negative 2x plus 4. Almost equals 0. I got a positive 7 over there. So now what I got to do is subtract it because it's positive. I'm going to subtract it from the positive 4 on the other side. Now that becomes 0. And I get x squared minus 2x minus 3. Okay, what do we do next? There you go. A, B, C. A is 1. B is negative 2. C is negative 3. So it's got to multiply to be 3 and add to be, oops, not 1, negative 2. There you go. So the two numbers that multiply to be negative 3 and add to be negative 2 are negative 2, or sorry, negative 3 and positive 1. Okay. So we take those back. So we got x minus 3 and x plus 1. Bottoms up. Do I have to do bottoms up for this problem? No, but it doesn't hurt. If you forget, always do bottoms up. If you're like, oh man, do I do bottom? Do it. Because it's not going to hurt it because I divide it by 1. So if I divide this by 1, it's still minus 3. If I divide this by 1, it's still positive 1. Okay? Difference of squares. Are any of these guys difference of squares? No, there's no square, first of all. There's only a minus here. 3 is not on my list. 1's on my list, but it's not minus, and there is no squared. So, nope. What's the last step? How do I solve them? There you go. Set them equal to 0, like you've done many, many times. Positive 3 as an answer. And looks like I'm going to get negative 1 as an answer as well. Okay, those are extraneous. Or sorry, we got to check to see if they're extraneous, right? Those are solutions. They are solutions. They're answers. We didn't do anything wrong so far. Step 1, 2, and 3, we didn't do anything wrong. But we have to check to see if they're both verified answers or they extraneous. Okay. So you can do this part in your head sometimes. Sometimes you have to write it out. So I'm going to check 3 first. So I'm going to plug in 3 everywhere I see an x. Okay, so instead of x, I'm going to write 3. So 6 times 3 plus 7. And then over here is 3 plus 2. So multiplication, 18 plus 7. 5 on the other side. Square root of 25 equal to 5. Is that a true statement? Yep. Yep. Square root of 25 is 5. Okay, now let's try the same thing, but for negative 1. Okay, so negative 1. 6 times negative 1 plus 7 equals negative 1 plus 2. So it's going to be negative 6 plus 7 under the square root. Is the square root of 1 equal to 1? Yes, it is. So they're both verified answers. They're both answers. So I'd have 2 boxes, positive 3, negative 1. Okay. Alrighty. Okay, so I want you to try number 5 on your own. Try that one. I'll give you about 5 minutes to try that, and we'll go over it together in about 5 minutes, okay? So give it a shot on your own. See what you come up with. Okay, so I got 2 answers here. I got 7 and 2. I haven't done step 4, though. I've done step 1, 2, and 3. It was already isolated. I squared it. I simplified it. I did A, B, C, all of that stuff, and I got 2 answers, positive 7 and positive 2. Now I got to check to see if those are verified answers or are they extraneous. Okay, so I'm going to plug in 7 first. So when I plug in 7, I get the square root of 4 equal to 2. Yep, that's true. The square root of 4 does equal 2. So 7 is a verified answer. Okay, and the other one is positive 2. So when I plug in positive 2, I get the square root of 9 equal negative 3. Is the square root of 9 equal to negative 3? No. That one's not a verified answer. That's extraneous. So 2 is an extraneous solution. So if they're asking for the solutions, we don't include 2. The only answer we put in is 7. If you put 2 and 7, it'll mark it wrong because 2 is extraneous. Okay? Sometimes what they'll do is the question will say, give me only the extraneous answers. Then in that case, you would only give 2 and 7 wouldn't work. Just depends on the question. This question wants us to solve. So 7 is the only answer we give. 1 box, 7, that's it. 2 is not an answer. Okay, so make sure that that you always check. Okay. All right, so number 6, last one, number 6. Okay, so number 6, how is number 6 different than the problems we've done so far? This one's got a cube, right? This one's got a cube root, triples, right? We're still going to follow the same steps. We're still going to follow step 1. Step 1, isolate. All right, well, this is the only thing on this side, so we don't have to do that. Step 2, instead of squaring, we're going to cube it. Because that'll get rid of the root, the symbol. That'll get rid of the symbol. So we have 2x minus 1. 3 cubed. What is 3 cubed? 27. 3 times 3 times 3 is 27. All right. Add 1 to both sides. Divide by 2. 14 as an answer. Last thing I want to do is double check to make sure it is a verified solution. So let's see, 2 times 14 minus 1. And then I have 3 on the other side. Okay. So the cube root of 28 minus 1, that's the same thing as the cube root of 27. So is the cube root of 27 equal to 3? Yeah, because 27 is 3 times 3 times 3. It's a triple. So if I break this one down, it's 3 times 3 times 3. So those would move out to the front. Nothing left. It would be 3. Verified solution. Okay. Okay, so we got about 20 minutes. What we're going to do is we're going to do a couple problems, a couple practice problems, and then we'll be done. We're going to do 2 practice problems, then we'll be done. Okay, so I'm going to pass out some